In a previous video I discussed initial disturbance, which is caused by that the sample does not have the same temperature as the calorimeter when the sample is charged into the calorimeter. I will here discuss 4 different ways of dealing with initial disturbances. And number 1 is simply to skip it. And I showed these results earlier. Carrot respiration, barley grain germination. Here we have a positive initial disturbance. Here we have a negative initial disturbance. We don't need to show this. We can cut the data and maybe write in the captions that we have done this. We don't show the first hour of the data, for example. In these 2 experiments, we don't need to, because there is no information. The reaction here starts, or the process starts slowly, ramping up. And here we have plenty of signal, more or less constant signal until 250 minutes. So we can skip the initial disturbance, maybe saying that we do so. And here I will show an example of where someone has really told the readers of his paper that there is an initial disturbance and that this should be skipped. Because here, this is a medical experiment, medical measurements, 5.5 hour data. And here we have a gray box for a little bit more than 1 hour saying thermal equilibration period, no data recorded. So here, these authors, they make it really very clear that the signal that we have here, which maybe goes from below and then goes like that, should not be evaluated, should even not be looked at. That's good. So that was the first, skip it. The second thing that one can do is to pre-thermostate. Pre-thermostate, so that the sample has the correct temperature, more or less, when it comes down into the calorimeter. So here is the calorimeter, or actually the thermostat of the calorimeter, and I will draw the calorimeter with its heat flow sensor and heat sink down here. So this schematic instrument is very well thermostated, and let's say it has a temperature of T1. So one thing that one can do is that we can get a second thermostat here with the same temperature, of course, and place our sample there during some time before the measurement, and then when we start the measurement we charge it into the calorimeter. Then it has more or less the same temperature as the calorimeter, and this will reduce the initial disturbance. The second way is, of course, to use the thermostat of the calorimeter as a pre-thermostat. This is possible in some calorimeters, not in all calorimeters. And the third way is what is commonly done in microcalorimeters. That is to have 2 pre-thermostating steps or equilibration steps in the calorimeter. So you first charge your sample to a position in the thermostat and leave it there for, let's say, 15 minutes. Then continue down for another 15 minutes and then go down into the measurement position. At every position here, the calorimeter will, or the sample will equilibrate to the calorimeter to the temperature of the calorimeter, and when it finally goes down to the calorimeter, the disturbance will be very small. So these are different ways to pre-thermostate your sample. And then we have number 3, and that is to initiate your process inside the calorimeter or inside the vial. And I will show one example where that has been done. This is a cement hydration measurement, and if you look at the time scale here, it says 0, 10, 20 minutes, and this blue peak, for example, it peaks after 5 minutes, and it's not possible to do a measurement like this by mixing cement and water on the bench, charging into the vial, putting the vial into the calorimeter. No, because then you get 30 or even more minutes of initial disturbance with no signal that you can evaluate. Now this has been done in another way. Now here the cement and water has been mixed inside the calorimeter, And to do that you need special equipment, and I will show an example of how such an equipment can look like. So here we have the vial. So we put the vial in the with cement in this case in the vial, and here we have syringes. So we charge one of the syringes like that with some water, and then we place this in the calorimeter to equilibrate so that it will reach a constant temperature. When we put this down in, well, when we have this in the calorimeter with a constant temperature, we can inject the water like that with a syringe and mix the sample, because we have a mixing motor here and the shaft. So there is a mixer inside the vessel or inside the vial. So we can start the measurement in the calorimeter. This is a good way. And it minimizes the disturbances, but it's not free from problems because there is mixing energy, friction and other things down here. So there will be disturbances also, but this is at least a way to avoid the initial disturbance caused by that the sample has the temperature of the room when you charge it. Now, number 4, and that is the Tian equation, or Tian correction. I would write Tian equation. This is a quite simple equation that removes the effect of the thermal inertia of the calorimeter. The thermal power that has been Tian corrected is the thermal power plus a time constant times the time derivative of the thermal power. So this is a simple model. It's not a perfect model, and it doesn't work very well for the initial disturbance, but it can at least decrease the effect of the initial disturbance. Like this here, we have this isothermal power, let's say of the insects that we're studying, and the signal initial disturbance decays like this. So here we can measure the true thermal power. The Tian corrected curve will instead look something like this. So here we can measure the true thermal power slightly earlier. So it's not a perfect correction, but it's at least better than not using it. There are other models where you, for example, have 2 time constants, and those models are better. And there are other more general models that can be used to correct for the thermal inertia of a calorimeter. So these are 4 ways to deal with initial disturbances, and maybe a combination of them is the best. For example, pre-thermostating and then Tian correcting. So the take-home messages of the 2 videos on initial disturbances are that there is usually an initial disturbance when you start a measurement in an isothermal heat conduction calorimeter, and do not mistake this for a signal from the process in your sample. And there are ways to reduce the impact of the initial disturbances. Thank you for listening and watching.